Hello, welcome to the Unit 2 test review so that you can retake your Unit 2 test. All right, the first question, determine whether each sequence is arithmetic or geometric, and then find the next three terms. So first we need to remember what these things mean. This type of sequence is any type of sequence that adds or subtracts by the same number each time. And then geometric is any type of sequence that multiplies or divides by the same number each time. That's kind of a simplified version of it. That's the way I like to think of it. There's actually more to the definition, but we're just going to stick with that for now. So we just have to figure out how we go from 2 to 4, then from 4 to 8, and then from 8 to 16. Now your initial reaction might be, oh, to go from 2 to 4, I add 2. But then if we go from 4 to 8 and we add 2, that would end up at 6, not 8. So we're not adding 2 each time. So let's look at it again. Go from 2 to 4, we could multiply by 2. And then if we do 4 times 2, that would give us 8. And then 8 times 2 is 16. So we are multiplying by 2 each time, which means that this is a geometric sequence. Find the first 4 terms of the sequence represented by the expression negative 12n plus 5. Okay, since we want to find the first 4 terms, we're just going to take 1, 2, 3, and 4, and we're going to put them in or input them for the letter. So I kind of like to make this as a table to begin with. You don't have to make it as an X and Y table, but that's how I'm going to do it. For the first term, I'm going to take negative 12 plus 5 times 1. I'm putting a 1 in. And then this is just calculator work. 5 times 1 is 5. Negative 12 plus 5 is negative 7. And then I'm going to do the same thing, but instead of plugging a 1 in, I'm going to plug a 2 in because now I'm finding the second term. And so 5 times 2 is 10, negative 12 plus 10 is negative 2. And then I go and I do the same thing, but this time I'm going to plug in a 3. 5 times 3 is 15, minus 12 is 3. And then I'm going to plug in a 4. Negative 12 plus 5 times 4. 5 times 4 is 20. 20 minus 12 is 8. So the first 4 terms, it may just be written as like negative 7, comma, negative 2, comma, 3, comma, 8. You don't have to make it a table like I did. That's just usually how I think. Determine whether each sequence is arithmetic or geometric, then find the common difference or common ratio. All right, so we're just figuring out how we go from each number. I usually check adding and subtracting first. To go from 17 to 13, I would subtract, what is that, 13? 4? Let's check that again. To 13 minus 4, that does equal 9, and 9 minus 4 does equal 5. So that works. So our common difference is negative 4, and since we're adding or subtracting, that means it has to be arithmetic. All right, the question is gone here, but we're just kind of looking at this graph and we're seeing what is happening in this graph. This is a graph of a car traveling. Notice time is on the bottom and the speed is on the side. So the car starts off at 25 miles an hour. For the first 5 seconds, it increases to 40 miles an hour. Then for the next 5 seconds, it stays at 40 miles an hour. This line here does not mean that the car stops. The car is still traveling at 40 miles an hour. And then it starts to decrease. So it's slowing down, it's braking. So for the last 5 seconds, it slows all the way down, and down here is where it represents a stop because that means it's going 0 miles per hour. So the car starts at 20, increases to 40, stays at 40 miles per hour for a little bit, and then slows down to a stop. All right, let's take a look at what's going on here. In this graph, we have like gallons on this side and then time over here. And again, we're dealing with a car and we're seeing what's happening to the gallons. So they start off, here we go. This is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. So this is actually 24 right here. I know it's not written there, but it's 24. So they start off with a full tank of 24 gallons. As they start driving, they start to use up their gas. By 6:30 p.m., they fill up their tank. And I know they fill up their tank because it goes all the way back up to a full tank at 24 gallons. And then they start to drive some more and they use more of their gallons. And then it looks like they stop right there at 12 gallons. So this is where they're filling up their tank. I'm not sure exactly what the question is going to ask you, but you just have to know how to read the graph to try to determine what the question is asking. If it asks like what time did they fill it up, you would look down here and figure out the time. If they asked you how many gallons they filled up, you could look at this and say, okay, they went from 14 to 24, so that's 10 gallons. There could be lots of different questions based off that graph. Which table contains input-output values for this function? Okay, so the way the question's worded, obviously it's going to be multiple choice, but we're just going to fill in the values. So I'm going to take my equation here and I'm going to plug in the x values to figure out. So I'm going to start by plugging in a 3 for x. 3 times 3 is 9, minus 7 is 2. And then I'm going to plug in a negative 4 for x. 3 times negative 4 is negative 12, minus 7, negative 19. And then I'm going to plug in a 5 for x. 3 times 5 is 15. 15 minus 7, I think that's 8. So that should be the correct table. Which table does not represent a function? All right, so in order to do this, we need to know what it means to be a function. For it to be a function, each input has to have exactly one output. So that's kind of a lot of words, but here's what it means. Well, let me type this up here first. So I typed it up here for us. Each input has to have exactly one output. So what that means, where's my pen? There it is. What that means is if I look at my x values, like on this first table, if I put a 1 into this function, every single time I put a 1 in, it has to equal 4. And when I put a 2 in, it has to equal 5. And when I put a 3 in, it has to equal 6. Each of those inputs only has one output. If I look at this one, when I put a 4 in, I get a 3. When I put a 4 in again, I get a 6. And when I put a 4 in again, I get a 9. That means the input of 4 is giving me 3 different outputs or 3 different y values. That cannot happen. That is not a function. I mean, it can happen. It just can't be a function because my input has more than one output. So this one is not a function. Now let's look at this one because this confuses people. When I put in a 1, I get a 4. When I put in a 2, I get a 4. And when I put in a 3, I get a 4. All that we're looking for is the inputs. We have to make sure that each thing that we put in only has one answer. So when I put in a 1, I always get the answer 4. It wouldn't work if I put in a 1, I got a 4, and then I got a 5, and then it has to always be the same. When I put in a 2, I always get a 4. When I put in a 3, I always get a 4. This one is still a function because each of these x values has exactly one y value. So the one that is not a function is this one. All right, we want to find the value of f of negative 4. And notice the negative 4 just replaced where we had x. So all we're going to do is we're going to take our equation, and where we see an x, we're going to plug in a negative 4. Negative 3 times negative 4 is positive 12. Positive 12 plus 2 is 14. So I should have written the whole thing. F of negative 4 equals 14. Oops, you can't see the question there, but the question says, what is the slope of the line? So if this was multiple choice, the very first thing that I would do is I would identify that this is a positive slope because it's going uphill. So I know the slope has to be positive, so if I saw any negative answers, I would go ahead and mark those out. And then I'm going to use either rise over run to count it on a graph or the slope formula. Since it's a graph, I'm just going to go ahead and count. Rise up 1, 2, 3, 4. So I rise up 4, and then I run over 1, 2, 3, 4, 5, 6. So I rise 4 and I run 6. I should write that out. Rise over run. And we're going to reduce that. So I'm going to go ahead and put that in the calculator or reduce it by brain. I'm going to divide each by 2. And my slope in this case is 2 over 3. All right, what is the slope of the function represented in the table? Since I did rise over run last time, I'm going to go ahead and use the slope formula. So the slope formula says y2 minus y1 over x2 minus x1. And it doesn't matter which point you pick. I'm going to go ahead and let this one be x1 and y1. And then I'm going to go ahead and pick the next 2 points just because the numbers will be smaller. So I'm going to let this one be x2, and this one's going to be y2. And then I'm going to plug them in. So 11 minus 3 over 2 minus 0. 11 minus 3 is 8. 2 minus 0 is 2, and then I'm going to reduce my fraction, and my slope will be 4 over 1, or 4. All right, so now we're looking at this graph, and we're trying to see which of these works. So the first answer says the slope of the hypotenuse of the red triangle is the same as the slope of the hypotenuse of the blue triangle. So remember, the hypotenuse is the side across from the 90-degree angle, so we're comparing that slope to that slope. And in this case, that is a true statement. Both of those slopes have to be the same because they are the same line. So that's true. I actually don't remember what the question was asking for, so let's just look at each answer. The slope of the hypotenuse of the red triangle is steeper. No, it's not going uphill more. That's false. The slope of the hypotenuse of the blue triangle is half the slope. No. Again, we're not looking at the length of the line. We're just looking at the steepness of the line, and both of those have the same slope or steepness. And then the other one is also false. So we're probably looking for the true answer here, which would be that one. Which graph represents the linear function? Okay, so this was a multiple choice question, and I'm just going to go ahead and graph it for you. So y equals 2x plus 4. This is in slope-intercept form. So remember, the one attached to the x is your slope. The letter or the coefficient with the x is the slope. And then the number at the end is going to be the y-intercept. So I always start graphing by the y-intercept. I find my y-axis, and I put a point on the y-intercept. And then I'm going to do my slope. Right now, my slope is not written as a fraction, so I'm going to make it a fraction by putting it over 1. And remember, slope is always rise over run. So from 4, I'm going to rise up 2 spaces and over 1 space. And you can do that as many times as you want. You can also go down 2 and backwards 1. But hopefully you will see that this is what your line should look like. Match the equation to the graph. Okay. So in the first equation, my slope is 1/2, and my y-intercept is -3. So I'm going to look and see which one crosses the y-axis at -3. It's this graph. So this one goes here. For this one, my y-intercept is +1, and my slope is 3. So I'm going to see which one crosses the y-axis at +1. It has to be this graph. And then here, my slope is -2, and my y-intercept is +5. I know this one has to match because it has a negative slope, and this is the only one going downhill. Also, the y-intercept is at 5, so that matches there. Last one. Write the equation of the line represented by the graph below. All right, so our equation of our line is y equals mx plus b, where m is the slope and b is the y-intercept. So the first thing I'm going to do is I'm going to figure out where that y-intercept is located. I'm going to look on my y-axis, and it crosses the right y-axis right there at -3. So I can go ahead and plug -3 in for b. And then I got to figure out my slope. So I'm going to pick another point on the line. Doesn't matter which point I pick. You notice there's lots of points here. I go up 2, so I rise 2, and then I go backwards 1. So that's going to be a negative slope. I rise up 2 and go backwards 1. Which that's usually just going to be rewritten as -2x instead of -2 or 2 over -1. So that is my equation. Good luck on your Unit 2 test retake.